Hey guys, today we're going to learn how to write or find the distance between two parallel lines, similar to yesterday, but honestly a little bit easier. So, first example, find the distance between the parallel lines y equals 2x plus 1 and y equals 2x minus 3. And if you look at the graph, you can see the picture there already. So step 1 says that you're going to write the equation of a line that is perpendicular to both of the original lines, and use a point that is on one of the lines. So I have two lines there. Let's say I were to pick, I think y-intercept would probably be the easiest. So if I were to pick that point there, let me use a pen. So that point, it's on one of the lines, so that's good. And I'm going to label it, so that is actually 0, 1. Now for slope, the slope of both of these lines, so it's given in the equation, and also you could just count it from the picture, is 2. So when I'm writing my equation, 0, 1 is my x1, y1. And for slope, since it's perpendicular, we're going to use opposite reciprocal, which means negative 1/2. So fill that into point slope form, and I'm filling in as I go. Okay, so the 0 here kind of doesn't make too much of a difference, so we could ignore that. We're just going to distribute the negative 1/2. And then adding 1 to both sides. That gives me y equals negative 1/2 x plus 1. Okay, step 2 is determine the point of intersection on both of the lines. So remember, we have to do this kind of like a system of equations. So we're going to use the equation that we have right now. I'm just going to write it here to the side. And then we need the equation of one of the lines that was above. The thing is, I already have a point on this first line, so I'm going to call this line 1. I need to find the point on line 2. So I'm going to use the equation of this second line, which happens to be this equation here. So we're going to use that one. So if you remember from yesterday, the way we set this up is we made both of these equations equal to each other. So negative 1/2 x plus 1 is equal to 2x minus 3. So there's x's on both sides. That's the first thing I would want to fix. So let's add 1/2 x to both sides, which leaves me with 1 is equal to 2.5, but we're going to write this as, I think a decimal would probably be better. So let's say 2.5x minus 3. Then let's move the 3 over. So now I have 4 is equal to 2.5x. And then last, divide by the 2.5. So this is going to give me another decimal, but let's see what we get. X is equal to, okay, that gives me x is equal to 1.6. Okay, but I also need to find the y value. So we're going to pick one of our equations, so one of these two equations over here, and plug it in. It's easier if you don't have any fractions, so I'm going to use the second one. So I have y equals 2, but instead of the x, we're going to plug in the 1.6 that we just found. 2 times 1.6 is 3.2 minus 3, which gives me that y is equal to 0.2. So our point of intersection is 1.6, comma 0.2. Okay, so I know that this is a decimal, but it still works the same way. So 1.6 and 0.2. If I were to draw my line perpendicular, I'm going to try to draw it as best as I can. It would be something like this. That's the point where they're intersecting. So right here, so you can tell. So now what we're looking for is, I want to find that distance in between. So 0, 1, that's the first point. And then the one that we just found is our second point. So we're going to use those 2 points to plug into the distance formula there. And I have it written down this time so that we can refer back to it. So distance equals 1.6 minus 0 and then squared plus 0.2 minus 1 squared. And this time around, we're just going to type everything directly into the calculator. So we get, so when I do this, I get 1.789. So that is the distance between those two lines. So a little bit less than 2. Okay, so to keep practicing, I have 2 more examples. I'm going to try to go through them pretty fast. So this time, my 2 lines are negative 3x minus 5, which is this one here. So I'm going to label that as first line 1. And then negative 3x plus 6 is the second line. So this line here. So we need to write the equation of a line that is perpendicular to both of these. So we're going to pick a point from one of the lines. I think it's always easiest to pick a y-intercept. So if you look closely, the y-intercept of the first line is right there where I drew the red dot, and that is 0, negative 5. So let's use that as our x1, y1. And because we're doing a perpendicular line, we want it to be perpendicular to the slope that we already have. So we're going to use positive 1/3. Okay, so filling this into point slope form, I would have y plus 5, because it's minus negative, is equal to 1/3 x minus 0. Distribute the 1/3. So y plus 5 equals 1/3 x. And then 1/3 times 0 is 0, so we don't need to write it. And then last, we move over the 5 by subtracting. So y is equal to 1/3 x minus 5. Okay, so I know that that line is perpendicular and it's going through the red point up here. So I'm going to try my best. Let's see. Something along those lines. So now I need to find out what this point is over here. So we're going to set up a system of equations with the line that we just found and with line 2. So line 2, sorry, let me go back and look at it, was negative 3x plus 6. And then the line we just found is 1/3 x minus 5. So we want to know where those two are equal. So let's go ahead and do that. Set them equal to each other. There's x's on both sides. So to fix that, I'm going to add 3 to both sides just because that's negative and I don't want to have negatives anymore. That gives me 6 equals 3 1/3. So we're going to call that 10/3 x minus 5. Then add our 5 to both sides. So 11 equals 10/3 x. And to get rid of that fraction, we're going to multiply by the reciprocal. So we're turning it upside down. So when we do that, we get 33 over 10 is equal to x. It might be a little bit easier to deal with this as a decimal. So let's say that x equals 3.3. Okay, but now let's plug that in so that we can get our y value. I'm going to use the top one, our equation 2, just so that I can not have decimals. Y equals negative 3.3 plus 6. So that would give me negative 9.9 plus 6, which gives us negative 3.9. So that point where it's intersecting is 3.3, comma, negative 3.9. So if I look at my picture, that does kind of make sense because here's my 3, so somewhere around there. But now what we're going to do is find that distance in between them. So if this is my x1, y1, and our new point is our x2, y2, we're going to plug that into our distance formula and see what we get. So I have 3.3 minus 0 squared plus negative 3.9 minus, or it's minus negative, so it's going to be plus 5 squared. And now all into the calculator so we see what we can get. Okay, this gets us 3.479. Okay, and that's how you find the distance between two parallel lines.